Okay, so what is the polarity of the transformer EMF at time equals 0? So we have the magnetic flux in blue changing as a sine omega t, and we have the transformer EMF changing in red based on cosine omega t. Now, if we want to know at time equals 0, we should look at the sine omega t and the cosine omega t, and we should think about what the polarity is going to be. And so at time equals 0, let's look at the transformer voltage. So if we look at time equals 0, we are on the red curve, which is cosine, and we know that cosine of 0 is going to be 1. And so because that cosine is going to be positive valued, that must mean that the d phi dt was greater than 0. And because d phi dt is greater than 0, that cosine is greater than 0, and that transformer voltage is going to be overall negative valued because we still have that negative sign out front in the beginning of our definition of the transformer voltage. So the total transformer voltage is actually going to be negative, and that's because n, the number of loops of wire, is a positive constant number. The omega, so the frequency at which the magnetic field is changing, that's going to be a positive number. Pi is a positive number. R, the radius of our loop, is a positive number. And we will consider B naught to be some constant to the magnetic field that is also going to be a positive number. So N, omega, pi, R, and B naught are all positive constants. And the cosine at time equals 0 is also a positive number. But we still have that leading negative sign, making the transformer voltage less than 0 at time equals 0. So this means that the polarity of the transformer voltage is negative. So point 2 on the bottom, where we have the negative sign, is at a higher electric potential voltage than point 1. And if point 2 is at a higher potential, that means that the current is going to flow from minus to positive at time equals 0. And that's backwards from what was defined by our ds using that right-hand rule. So the current is flowing in the opposite direction from what had been defined based on the right-hand rule from ds, which means that we will call the polarity of the transformer voltage negative here. So it's a negative polarity.